After the oil crisis of the early 70s, many creative ideas to save oil have led in 1986 to the development of clean oil microfiltration. Amongst the many areas of application, the use of clean oil microfiltration offers the biggest advantages when used in hydraulic and other similar systems. The idea that hydraulic oil is clean is wrong, as is the assumption that with a simple oil change, the contamination can be taken from the system. A large part of the contamination is within the system. With the oil, the contamination, usually consisting of water or various particles, gets into the entire system. Within the hydraulic pump, the particles are broken up. This results in an increased wear on all surfaces that are only protected by an oil film. Softer particles crumble. Water particles damage components due to cavitation. All particles are reduced in size, and it is difficult to filter them out with a system filter. The combustion engine that powers the hydraulic pump also suffers from similar contamination problems in its lubricating oil and diesel fuel. In order to improve engine life and reliability, the diesel fuel and engine oil must be kept clean. Contamination in the diesel fuel damages the injection system, and so reduces performance and leads to breakdown and expensive repairs. In order for the combustion to take place, the engine needs a large quantity of air. The air carries particles both large and small. The air filter is a compromise between flow and filtration, hence some particles enter the engine with the air. These particles cause wear in the engine and can enter the engine oil via the piston rings and valve guides. All engine components below the combustion chambers are protected by an oil film. It is therefore essential that the engine oil is absolutely clean. Any contamination that reaches the engine oil causes abrasive wear of all metal surfaces. In extreme cases, and especially if increased quantities of condensate reach the engine oil, this leads to the formation of acids and premature aging of the oil. The most severe mechanical wear is experienced on the highest mechanical stress points on the crankshaft. This is effectively the backbone of the engine, and damage here will almost always result in complete engine failure. As soon as mechanical and liquid contamination reach the engine oil, this leads to premature aging and increased wear to the engine's components. Gases reaching the engine block from the combustion chamber can contain chemical components which, in combination with water vapor, can facilitate the formation of harmful acids. The result is a chemical attack on the engine's components and the engine oil. Clean oil bypass filter rigs enable an effective cleaning of systems. Due to wear, it is inevitable that contamination in the form of various sized particles occurs. Tolerances within valves are often only a few microns, meaning their function will be influenced negatively by even the smallest particles. This results in malfunctions, loss of performance, and increased oil temperature. Larger particles may even cause total breakdown. Clean oil microfiltration, installed in a bypass loop, is highly effective due to the fact that all harmful contamination is filtered out or absorbed. The oil is passed radially through the clean oil filter cartridge. Solid particles down to a size of less than 1 micron cannot pass through the cellulose fibers of the filter cartridge. Water droplets are absorbed by the cellulose while the oil passes through. Any particles that do pass through the filter cartridge will be retained by the safety plate at the bottom of the filter cartridge. Clean oil bypass filters that are installed as an integral part of the system are highly efficient. The KLEENOIL ICC oil analysis sensor makes for the ideal combination, analyzing oil in real time. The result is displayed on the panel in a way that is easy to understand. We call this principle the integrated fluid concept. Machines with clean oil microfiltration, that is with clean oil, are up to 20% more efficient. In practical comparisons, well-known construction machine manufacturers have arrived at the same conclusion. From a technical point of view, it is more sensible to carry out oil filtration and regular analyses instead of regular oil changes. In both cases, even with the less costly and technically advanced long-time concept by KLEENOIL, there is still one question unanswered. Is the oil in perfect condition within these intervals? The highest security is offered with the integrated fluid concept by KLEENOIL due to continuous bypass microfiltration and oil analysis with KLEENOIL ICC. The oil analysis is now done every 30 minutes. Clean oil microfiltration can be used in practically any hydraulic system. Control systems and components are protected, performance maintained, oil resources conserved, energy consumption and total cost reduced. Clean oil technology combines technical advantages, efficiency, and environmental protection.